So let's solve this question. This is also a variable coefficient together with an initial value problem. So it means that after getting the general solution, we will apply the initial value to get a particular solution. Alright, so solution. We have t y prime plus 2y should be equal to 4t squared. Now the next thing we have to do is to divide through by t. We are supposed to arrange this one in the standard form, and in the standard form the coefficient of y prime should be 1. Therefore we divide here by t, divide here by t, and also divide here by t. So we will get y prime plus 2y on t then should be equal to 4t. So that's the first step. The next thing is to look for the integrating factor. The integrating factor is giving us e to the power the integral of the coefficient of y here, which is 2 on t dt. So let us solve that. The integral of 2 over t dt. We know that when we integrate 2 over t dt, we will get this whole thing becomes 2 ln t. So this is what you will get. And applying the laws of indices, we will get e ln t all squared. This e will cancel the natural logarithm and we will get t to the power t 2. So we have our integrating factor here to be t squared. The arbitrary constant is not important because when we multiply it through, it will cancel, so there's no need of bringing it. So that is our integrating factor. The next thing is to multiply through by this integrating factor. So I'll multiply this by t squared. So I'll get t squared y prime. Then I'll also multiply here by it. So I'll get t squared plus t squared multiplied by 2y over t. Then should be equal to t squared multiplied by 4t. So let us simplify. I have t squared y prime plus, if I cancel out, I'll get 2t multiplied by the dependent variable y should be equal to 4t cubed. Alright, so the next thing we have to do is to simplify the left hand side. If we simplify the left hand side, we will get the integrating factor, which is t squared multiplied by the dependent variable y. Then all together you find its derivative. This is the product rule. When you simplify this, you get this. So all this one should be equal to 4t cubed. Now the next thing here is to integrate. When we integrate both sides, we will get t squared y because the integral sign will cancel the derivative. and here becomes 4 over 3. No. When we integrate here, we will get 4t exponent 4 divided by 4. So finally we will get t to the power 4 plus the constant c. Remember here, we are to integrate with respect to the t. So that is the concept. Now from here, I can bring the t to the power 4 here, and I'm left with the constant c. But if I differentiate, then I will get 0. Or the derivative of a constant is 0. Now, this is what we call total derivative. And what is in the bracket is called the potential function. Always the potential function is written in a functional notation. It is a function of the dependent variable t and the independent variable y. And if I should take its derivative, let me put it here, if I should take its derivative, then I will get 0. So it means that our potential function is always equal to a constant c, and that potential function is what is inside the bracket, which is t squared y minus t exponent 4 should be equal to the constant c. Now from here we can find y by dividing through by t squared. If I divide here by t squared, divide here by t squared, and I also divide here by t squared, I'll get y minus t squared should be equal to c on t squared, c on t squared. So this is what I'll get. I can make y the subject. Let's make y the subject. If I make y the subject, then I'm going to get t squared plus c over t squared. So this is what I'll get. But looking at the initial value condition, our initial value condition is that y1 is equal to 2. This means that t is 1 and y is 2. So let's substitute it here. We will get 2 is equal to 1 squared plus c over 1 squared. So we have 2 is equal to 1 plus c, and c is equal to 1. So our c is 1, and we can substitute it there. So we have y of t, that is, y is a function of t, should be equal to t squared plus 1 over t squared. And that is the final answer.